Hello everybody! Today we're going to continue with our division and we're going to shift from using our place value chart to now using an area model to solve 3-digit dividend division. So on Tuesday we were looking at 3-digit numbers divided by a single-digit number and we were using our place value chart. Hopefully you got the hang of that, and now we're going to shift to using our area model. So we want to eventually, not right away, we want to eventually move away from having to use our place value chart and even having to use an area model and eventually be able to use something like just partial quotients. But for now, we really want to make sure that area model is something you're comfortable with. So let's take a look. We have 297 divided by 4. I have a lot of you who are still really liking using a bond to decide how you want to break up your number. I am really fine with that. I think that's a great model just to be looking at and thinking about how you want to break your number up. Now, because we're thinking about 3-digit numbers, there's a little more to consider here. Remember, the key piece is to choose numbers that you can divide by our divisor. Okay? So choosing to break this up into a 200 and a 90 and a 7 is not going to be great because 90 is not easily divisible by 4, nor is 7. So we want to think about how can we break these numbers up into ways that we can easily divide by 4. Now, I'm not sure if you know, but I know 200 is divisible by 4. Maybe you don't know that, but maybe you know 100 is divisible by 4. So you might want to think about breaking it up into 100. And another 100, that's the 200. Now we've got 97 left. And 90, I know, isn't divisible by 4, so I'm going to use 80, because I do know 80 is divisible by 4. Now I have 17 left. I also know 17 isn't divisible by 4, but I do know 16 is. And then I know I'm going to have 1 left over because I wanted 17, but I couldn't do it, so I'm just going to mark this as my little remainder over here and remind myself, okay, I know I'm going to have a remainder in this problem. So now I've kind of broken up my 297 into ways that make sense for me that I also know each of those parts is divisible by 4. So I'm going to set up my area model. And you guys are getting pretty good at area models, and I haven't been too picky up till now, but I'm going to start being very picky about making sure that all of the parts on your area model are labeled properly. So we know we're going to have 4 on the side because we're dividing by 4. And I'm going to break up this area model into a chunk of 100, into another chunk of 100, into a chunk of 80, into a chunk of 16, and then I already know I'm going to have 1 little leftover remainder, so I'm going to stick it right over there. I'm going to put 1 in there, okay? Now we can think about how we're going about dividing this. So I'm going to even write underneath my division problem. I'll list them on the right, I guess. So I know I'm going to have to do 100 divided by 4. And I know it's 25 because I know 4 quarters make $1. So 4 25 cents, quarters are 25 cents, make 100 cents, right? I know that. So I know this part here of my area model is 25. If I know that, I also know that the other one is 25, okay? Now I've got 80 divided by 4. Well, we know 8 divided by 4 is 2, so 80 divided by 4 is going to be 20. And I know 16 divided by 4 is 4. So notice how I labeled each part. I want you to be sure you're starting to do this. Label each of those parts that you divided by. And then to find your actual quotient, you're going to add all of those parts up. So all of these numbers here are going to be added to find your total side length. And I would like you to note that on your area model. Some of you like to put these numbers on the bottom and the total at the top. It doesn't matter if it's on the top or the bottom as long as you've got it labeled. So I know I've got to add 25, 25, 20, and 4. And that's going to give me, let's see, 50, 74. So I know this side length is 74 with a remainder of 1. Don't forget that remainder over here, guys. Okay? So don't forget that you've got a remainder. So I know my quotient is 74 with a remainder of 1. Okay? I've listed my division problems on the right. I've made a number bond should I wish to, and I've broken up my 297 into parts that are easily divisible by 4 so that I don't get left with a bunch of weird remainders. Let's take a look at one more example. This is kind of a neat one because this is a real life example. There are 365 days in a year, and there are 7 days in a week. And if I do this division problem, we're going to find out how many weeks are in a year. Okay, so once again, I'm going to set up my bond. You don't have to make a number bond. If you are confident and comfortable in just using your area model, a number bond isn't necessary, but I've noticed a lot of you like to use it, so I'm going to model that. This one's a little bit different because you'll look and see I've got 300s, and I know 300s is not easily divisible by 7. So I can't break it up like that. So I'm going to think about what's a 30-something that I know is divisible by 7. So I'm going to count by 7s until I get into 30s. 7, 14, 21, 28, 35. So I know I could use, 350 as one of my sections. Thinking back to Monday's lesson, right? We were thinking about multiples of 10, 100, and 1,000 that we could divide by single-digit numbers. So because I couldn't divide 300 up nicely, I thought, okay, well, I'll think about 300 something. Right? If that doesn't work for you, go by 70s or try to find something larger. I know 350 works. 65, sorry, erase that. So I'm going to go with 350 because I know 35 is divisible by 7, so 350 is divisible by 7. Do you see how that works? Now I know there's 15 left, and I know 15 isn't divisible by 7, but I do know that 14 is, and then I know I'm going to have 1 left over as my little remainder, so I'm going to mark that. Now I'm going to start making my area model. I'll label my side length here. I know I'm going to break it up into a big chunk of 350, a smaller chunk of 14, and this is not to scale. I feel like I should put my 14 even smaller. And then I know I'm going to have that 1 remainder. So now I'm going to go ahead and divide each part. So I'm going to do 350 divided by 7. Well, I know 35 divided by 7 is 5. So 350 divided by 7 is 50. And then I've got 14 divided by 7, which I know is 2. So I'm going to add those 2 parts up here, 50 and 2. And I get 52 with a remainder of 1. 52, remainder 1. And I'm going to label my whole side length here as 52. And that is true. There are 52 weeks in a year, but we have one remaining day. This is why we have a leap year every 4 years. So with that, I would like you to go try 4 different problems using an area model. Make sure you include your labels on your sides, your labels on the insides, your label for the total amount, any remainders if you have one. And then I want you to be sure that you actually write your division problem with the quotient to match. I did not put those boxes in there, so you need to remember to actually write the division problem for me. I would also like to see you writing these out. Okay, I want to see your partial quotients. The number bond is optional. The area model and the partial quotients is not. Okay, good luck, have fun, let me know.